Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on McMurray half-bridge inverter and McMurray-Bedford off-bridge inverter. So now here, this is the circuit diagram of McMurray half-bridge inverter. First I will explain McMurray half-bridge inverter. After that McMurray-Bedford half-bridge inverter. So first here, we are using two main thyristors T1 and T2. T1 and T2 are the main thyristors. This is the main circuit. And D1 D2 are the two main circuit consists of T1 and T2, and D1 and D2 are the two diodes, main diodes. So here T1 and D2 are connected in anti-parallel fashion. So now here T2 and D2 are also connected in anti-parallel fashion. And next, these are the T1, TA1 and TA2, and DA1 and DA2 are the auxiliary thyristor. This one auxiliary thyristor, auxiliary circuit. This one is the auxiliary circuit. So now here TA1 and TA2, TA1 and DA1 are here same way here connected in anti-parallel fashion, and D2 and R2 are connected in anti-parallel fashion, and RD another auxiliary components are here. So here RD and C and L are the commutating elements, and next here this to turn off T1 and T2 we are using this auxiliary thyristor and supplies VDC by 2. This is VDC by 2 plus N minus plus N minus. Here this L. So L is the inductor. So now here this what is the main purpose of inductor? So this inductor main purpose of is to limit the di by dt to safe values in the auxiliary thyristors and main thyristors. What are the auxiliary thyristors? TA1 and TA2. And what are the main thyristors? T1 and T2. To limit the di by dt to save the safe value. So that is for di by dt limitation we are using this L. And next here the function of capacitor is to provide the energy required for the main thyristors T1 and T2. And next, what about the auxiliary thyristors are used for commutating the main thyristors? So these are the T1 and T2. To turn off this T1 and T2, so we are using the auxiliary thyristors for commutating to turn off the main thyristors T1 and T2. So this, because of this reason, so this is auxiliary commutated inverter. This bridge is known as an auxiliary thyristor inverter. So now here in the original inverter circuit is given by McMurray elements are DA1 and DA2. And RD were not present. So in the actual off-bridge inverter circuit, this is T1, and next this is T1, and this is VDC by 2, and next this is VDC by 2, and this is the load. So now here this is the VDC by 2. So this is the circuit diagram for off-bridge inverter. So in that there is no DA1, DA2, TA1, TA2 and RD. All these are not present. So now here DC supply is given to off-bridge inverter, that is added. So now DC supply 3-wire. So 3-wire DC supply is required. So the term off-bridge inverter is added inverter. So now this is the circuit diagram. Here current commutation is we are using to turn off the T1 and T2. So here current commutation, this point is important. Current commutation we are using. And next here this load is here RL load. This load current is constant because highly inductive load we are using. So these are the assumptions. So first here load current remains constant. Highly inductive load we are using RL load. These are the assumptions. Total 3 assumptions. So first load current is constant, means here we are using the RL load. So here SCR diodes and SCRs are ideal switches. So all the auxiliary thyristors and diodes, main thyristors and diodes means SCRs are ideal switches. Inductor L and capacitors are also, these inductors and capacitor also ideal. They have no resistance. So these are the 3 assumptions. And now here So this inverter operated in 7 modes operation. In the first mode operation, so what will happen, let me change the color over here. So now here, what will happen in the first mode operation? So first T1 thyristor will conduct. So T1 thyristor will conduct. So the T1 switch will conduct. And now here this is the load. So now here this is the load. This is the load. So like this, the switch will conduct. This is the I-T1 and this is the I0. This is the load current I0. So now here capacitor is charged with right positive load. This capacitor is charged to voltage Vs. So plus and minus, that voltage is Vs. This capacitor is charged with right hand plate with positive. This is right hand plate with positive, and that voltage is this Vs by Vs. And now here this is IT1 equals to, here IT1 equals to, same current flows through this one, IT1 equals to I0. So this is the case. So here in this way current flows, and here this is positive and this is negative, means here this is a negative and this is a positive, means it is in TA1 is in forward blocking mode, not forward conducting mode. It is in forward blocking mode. In the next mode, when you will trigger the TA1 gate pulse and it will be turned on. So in that case, that is forward conducting mode. So now here in this mode, T1 is conducting. So commutation is passive in this mode. So now here T1, how it will be turned off. So here forcibly we are turning off T1 and T2, forced commutation inverter. So now here IT1 equals to, load current is constant, IT1 equals to I0. This is one point. And here capacitor is charged with positive, or with positive plate right hand side, and next the capacitor voltage is Vs. And now here another thing is, um, uh, here we are not giving any gate pulse at t equals to 0. So now here in this case, in the first mode operation, so this is the case. So now here IT1. So what about the IT1? So here I0 current is here. This is the IT1 current. This is the IT1 current. This is the load current. Load current is I0, and this is the IT1 current. This color. This IT1 current is also I0. So IT1 equals to I0. So this is the case. IT1 equals to, this is IT1 is also IT1 and I0. So I0 is here IT1. And next, what about the capacitor voltage is plus Vs. So this is Vs and this is plus and minus. So this is the capacitor voltage Vc equals to Vs. This is the case. And now here next second mode operation. So now in the second mode operation at t equals to 0. So now here TA1 is turned on. So it is in forward blocking mode in the mode 1 operation. In the mode 2 operation, what will happen? TA1, so auxiliary thyristor, not main thyristor. TA1 is turned on. So in the second mode operation, auxiliary thyristor TA1 is triggered at t equals to 0. So now here initially it is conducting like this. So this is mode 1. So IT1 and this is a I0. So now here in the mode 1 operation, IL current, this is open circuit. IL current, IC current, both are 0. This is I0. But here we are giving triggering pulse to this IT1, auxiliary thyristor T1. So what will happen? Current, this capacitor voltage, capacitor is discharges through this TA1, through L. Uh, the capacitor is discharges through L T1, and next here this auxiliary thyristor and again C. So when TA1 is fired, capacitor starts discharging. So it starts building through resonant circuit. So it discharges through L, T1, TA1 and C. So this is the case. So now here what will happen? So now here current is flowing like this, and this current is flowing like this. Now if I apply KCL at this node, sum of entering currents equals to sum of leaving currents. So now here IC current is entering. So IC current is entering, IC current equals to, so now here IT1 current is also entering, IT1 equals to I naught. So this is the, if you apply KCL, sum of enter, this is entering current, this is entering current, this is leaving current. So now here IT1 current equals to, IT1 current equals to IT1 current equals to I naught minus IC. So this is the case. So I naught minus IC. So now here this is discharging current, IC current. So now here what will happen? IC current is increasing. Initial IC current is 0. Let me change the color over here, red color. So now here this current, when this IC current is increasing, what will happen? So voltage across the T1 is reverse biased. So D1 is reverse biased. D1 is reverse biased and T1 is in forward blocking mode, forward conducting mode. So when it is up, it is reverse bias up to T1 is conducting. So now here, so they are connected in anti-parallel fashion. One is in forward bias, another in reverse bias. So now here, so T1 at constant I naught. So IC is increasing. When IC is increasing, this current is increasing. This IT1 current will decrease. So this IT1 current will decrease. So now what will happen? I see when IT1, when I naught equals to IC, what happened? So IT1 current will be 0. IT1 current will be 0 means this current will be 0 means it will be turned off. So as I naught current is constant, so increase the IC current, increasing the current IC current that causes, so IT1 current will decreases. So when it will be decreases, it is increasing means, so here when I naught equals to IC, so IT1 current will be 0. As a result, so T1 will be turned off. So this is the second mode operation. So now here, so IT1 current is decreasing. So initially it was I naught, it is decreasing, and IC current. So this IC current is increasing. So now here in this case, so in this case D1 will be turned off. So now here when it is reaches to this IC current I naught, so IC current I naught, so D1 will be turned on. So this D1, so when it will be turned off, T1 will be turned off, and so they are connected in anti-parallel fashion. One is connected in, one is in forward bias, other one is in forward. When T1 is off, automatically D1 will be on. They are connected in anti-parallel fashion. So now here IC current is increasing and IT1 current will decreasing. So IT1 equals to IC minus I naught minus IC. So IC current increases, this is increases means this current will decreases. So now here this voltage is also some discharging, and next here this is the case for second mode operation. In the second mode operation, T1 will be taken, so IC current will increases, IT1 current will decreases, and IT1 current will 0 when IC equals to I naught. So at that particular case, T1 will be turned off and D1 will be turned on. So now here in the third mode of operation, so in the third mode of operation, what will happen? So in the third mode operation, let me change the color over here. So now here in the third mode operation, so in the second mode operation, so here this is the case. So here this is the load, and next D1 will be conduct. D1 will be conduct. So now this is the D1. So current is discharging through this one. So IT1 is open circuited. So now here ID1, and this is the ITA1. So ITA1 equals to, always ITA1 equals to IC. So same current, they are connected in series, and this is the I naught. So now here again this capacitor is discharging. So this capacitor is discharging through this diode D. So now again this T1 and this C and this L. So this C discharging through L and this one. So now here how the D1 will be turned off. So that I will explain. After T at resonance circuit, so IC exceeds. So this current will. So this is discharging, but this current will, capacitor current will increasing up. So it will increasing. So IC minus I naught minus IC, IT1 current will decrease. So now here ID current equals to ID1 current equals to, same apply KCL at node B. So now here this IC current is entering. So IC current is entering, ID current and I naught current is leaving. So now here IC current equals to ID1 current plus I naught. So now ID1 current is equals to IC minus I naught. So now here what will happen? Now, this current IC current exceeds the I naught current. So what will happen? So IC current exceeds the I naught current. So the excessive current, so uh, that current circulates to this feedback diode D1. So now here, because of this D1, what will happen? This D1 reverse biases the T1. So to bring the forward blocking for forward conducting mode to forward blocking mode. So when the capacitor voltage discharges to 0, so here initially it was Vs in the first mode. In the second mode it is decreases. When it is decreases to 0, so this capacitor current towards the maximum value, that is ICP. So towards the maximum value, that is IPCP, capacitor current increases beyond means increases exceeds up above the uh, load current I naught, and when it is reaches towards the ICP, when ICP VC is equals to 0, and in that case, that is the case. So IC equals to ICP, capacitor current is the maximum value. So now here, after attaining the ICP, IC current begins to decrease. So after current IC current begins to decrease, and so C begins to charge. Initial case it is discharging, now it is charging case. So now here in the reverse direction. So that I will explain in the next slide. In the waveforms at T equals T2, IC falls to I naught. In that case, so somewhat more than the Vs at T equals to D2, and D2 will get forward bias, and it starts conducting. So now here what will happen? So now here in this case, first if you see, so this is the mode 2 at the mode 2. So capacitor is discharging. So this is at T equals to T1, capacitor is discharging. So when it is reaches to 0, capacitor current is beyond exceeds this I naught and increases to maximum value towards the maximum value, that current is ICP. When VC equals to 0, so in that case IC current is 0. IC current is 0. So now here IT1 current is increasing. So now here diode current. So diode current is increasing, and again maximum, and again decreases. And when it is discharging and increasing current up to maximum value. When it is reaches to maximum value, current will decreases. So when it is reaches to maximum value, current will decreases, and again voltage charges in reverse direction. So capacitor is charges in the reverse direction, that is minus, and so this is plus. Earlier it was plus and it was minus. Now it is plus and this is minus. So minus Vs. So it is minus Vs. So this is the diode D1 current. D1 current. So now here one question here. So here during when D1 is conducting, so T1 will be turn off. What do you mean by circuit turn off time? Circuit turn off time means time for which the SCR is in reverse bias mode. So when SCR will be in reverse bias mode, it will be turned on. So when it will be forward bias mode, so it will be turned off, means it is in reverse bias mode. So when diode D1 is conducting, so this is the circuit turn off time. So this is circuit turn off time. So now at the end of mode 3, so at T2, so D1 will be turned off. So this is minus and this is plus. So this is minus and this is plus, means this is the D1 will be turned off. And so when it is exceeds the Vs, this is when this Vs is exceeds some more than this voltage, capacitor voltage exceeds this Vs value, D2 diode will conduct. So that I will explain. So when it is exceeds this one, D2 diode will conduct. So D2 the diode will conduct. So that is So after T2, IC current extends to falls to 0. Current falls to 0. This IC current at mode 4 operation. So now at mode 4, IC current falls to 0. Diode current IT1 becomes 0, and therefore it stops conduct. So this is the case. This is the case. So now here this is the case. So now here, so what will happen? IC1, this is the IC1, IC, and this is the ID1, and this is the I0. So now here IC equals to ID plus I0. So now here, so when IC current falls to I0. So now when IC current falls to I0 means, this is I0 means ID1 current is 0, and again this is minus, this is plus, and this is minus, means here it will be turned off at constant current. So I0 continues to, so it is IC current, earlier it was maximum value, again it is decreases to I0. So that is the case. So ID1 current is 0. So D1 diode stops conducting. So now it is in reverse bias, and now here constant load current I0 continuous flowing through Vs by 2. So this is open circuit. In the fourth mode operation, it is open circuit. So now here this is open circuit, T1 is open circuit, and D1 is open circuit. Now current is flowing like this only. So IC equals to I0. So now here IC equals to I0 current. So now here capacitor, this is load. So now here I0 is continuous, current is going to Vs by 2 TA1, and next is CL, and again this load come back to this load. So now here load current is charges, so linearly with a reverse polarity at T3 somewhat. So now here that is more than, so now here the more than this one at T3. So now here in this case D2 diode will conduct. So D2 diode will conduct. So now here this is the case. So this is the case. These are the case. D2 diode will conduct, and so when D2 diode will conduct, so what will happen in the fifth mode operation? So when D2 diode will conduct, so at T3, so VC becomes more than Vs voltage. So now VC voltage more than this Vs voltage. If suppose this Vs more than Vs voltage, what will happen? Diode D2 gets forward bias. Diode D2 gets forward bias. So alternate path for I0 is provided. So now here what will happen? So load current is now shared by resonant circuit. So now here, so this current is path flowing through Vs by 2. So this one, again another path is here like this. So this is the case IC, and next this is the I0, and this is the ID2, not ID1. So now here ID2 equals to ID2 plus IC equals to I0. So now here ID2 equals to I0 minus IC. This is the case. So now here IC plus ID2. So this is IC plus ID2 equals to I0. So ID2 equals to I0 minus I. So now here this current. So here whereas ID2 starts build up. So now the sum of IC plus ID2 equals to 0. The supply voltage Vs, this is through D2 and now impressed across the resonant circuit. So now here IC current falls from I0 to 0. So initially it was I0, IC equals to I0, there is no diode current. So now here this IC equals I0. So now from the I0 to 0 value, so falls decreasing to I0 to 0. So now here energy stored in the L is transferred to the C, and so consequences capacitor is overcharged to the peak value, so that is at T equals to 0. So now here IC current is I from the I0 to 0. So IT1 current is turned off. So here IT1, so this is the case. So now here this is also IT1 current is okay. This is already turned off. So ITA current and ITA current. This is a ITA current also here like this. ITA1 current. So up to this one is also decreases. And diode D2 current will increases, and it is maximum at capacitor voltage is maximum. So this is the case for mode 5. And the mode 6 operation, what will happen? So this TA1 will be turned off and DA1 will be turned on through this L and this one. And next here, this is the diode case here. This is the case. So now how DA1 will be turned on and TA1 will be turned off. So this is a minus and this is a plus. So this is the ID1, ID1, ID2, and this is the I0. So now here, so here what will happen? So current is in reverse bias. So ID2 rises to I0. So here ID2 rises to I0 at that time. So sometimes IC falls to 0. And now here IC current will not be 0. It tends to in reverse direction. Initially it was in this direction from left to right, but here right to left. So here this is not case. So now here this current is in reverse, IC current is in reverse bias. And now here in this case, IC current is in this case means, so T1, TA1 will be turned off. It will be turned off. And now here it will be turned off and capacitor is, so here discharges through, this capacitor is discharges through here. So L, so now here C and this VD2, and next here RD and this voltage also. So here in this way it will be discharges. So now here L, C, RD, DA1, L and this VDC. So here current is negative. So current is initially 0 and it is negative maximum and it reaches to 0 again. So now here the negative current as flows, ID2 equals to IC plus I0. So if you apply KCL here, if you apply ID2 equals to I0 plus IC. IDT equals to I0 plus IC. So now when IC current will 0, when IC current will 0, ID2 current equals to 0. At that case, what will happen? This DA1 diode will be turned off. So now here this DA1 will be, so this DA1 will be DA1 will be turned off. So now here when it is reaches to maximum value, this is in reverse. When it is increases and it is maximum value, again it will decreases and this capacitor is discharges. So now in the reverse direction. So now here this I0 and ID2 current will also decreases. So now here in the seventh mode operation, what will happen? This is the case. DA1 will be turned off and this is the case. This is ID2 and this is the I0 case. So in this mode only a conducting device is D2 and device is only D2, and a part of energy is stored in the load is delivered to the source, and the decreasing load current I0 equals to IT, I0 equals to ID2, and it becomes 0 at T equals to T6. And now here the main thyristor T2 is already gated on after and TA1 is fired. So now here this T2 will be turned on. T2 is already gate fired after TA1 is fired, but it will not get turned on at the moment because of the reverse bias applied to it. And next at T6 equals to 0, ID2 is 0 and T2 is no longer reverse bias, it will be turned on and the capacitor charged to the minus Vs, it is already it is ready for the next commutation process. So in the half-bridge inverter, so when T1 is on, T2 is off and T2 is on and T1 is off. So these are the 7 modes operation. So I0 current and ID2 current, so both are in Z, decreasing, and again it comes back to 0 when it is reaches to the minus Vs. So now here, so T2 will be turned on. This is the turning off process of T1 and again T2 is turned off, and next T2 to turn off the T2 thyristor. So we will use DA2, TA2, and next T1 D1 thyristors will use to turn off T2. So now here in the full bridge inverter. So full bridge inverter. So this is the this is in the previous one we studied. So McMurray full half bridge inverter. This is the full bridge inverter. So what are the elements in this here? So this is the main thyristor. So this is the main thyristor, and this one is the auxiliary thyristor, and this one is a load. So total in the main thyristors T1, T2, T3, T4 thyristors, and D1, D2, D3, D3, D4. So four main thyristors and four main diodes. So these diodes and thyristors are connected in anti-parallel fashion. This RD and LNC are connected. And to commutate this, to turn off this T1, T2, T3, T4, so we are using auxiliary thyristors and auxiliary diodes. So this is the auxiliary thyristors. So this is the main thyristor, and this is the load. So now here TA1, TA2, so this is TA1 and TA2 and DA1, DA2. So these are the main thyristors. Auxiliary thyristors, they are also connected in anti-parallel fashion. So now here this in this process also same like full bridge inverters. So when T1, T2 will be turned off and T3, T4 will be turned off. So that we will that is the case. In the previous one, only one thyristor will be turned on, another thyristor will be turned off. So now here McMurray Bedford off bridge inverter. So what will happen? So here how two thyristors T1 and T2 thyristors connected. So this is the circuit diagram for our McMurray-Bedford off-bridge inverter. So in this L1 and L2 are connected, and next C1 and C2, and diodes, feedback diodes D1 and D2. This is the supply and this is the load. So load current is RL. So assumptions are load current is constant. So this L1 equals to L2 equals to L, same inductance, and C1 equals to C2 equals to C, same capacitance. So now here this inductors are connected. So inductors are connected. So with the same core, connected on same core. So here that core is air gap, same core with air gap. So to avoid the saturation, so here air gap core, that is we are using. So it is a center tapped here. So now here what will happen? Mode 1 operation. So it will operated in the four modes. So in the first mode operation, what will happen? So in the first mode operation, what will happen? First T1 is turned on. So T1 means here S1 indicates here T1. So here T1 will be turned on. So that is the case. So this is the case. This is the case. And again what will happen? So this is the case here, this capacitor. So here another assumption is, so T1 and T2 are operated in complementary mode operation. So when T1 is turned on, T2 is turned off. When T2 is turned on and T1 is turned off. So if one thyristor is turned off, other thyristor is turned on, and other thyristor is turned off, and this one is first one thyristor is turned off. So it is a complementary commutation process we are using. So this inverter is also McMurray-Bedford inverter, half-bridge inverter is also known as a complementary commutated inverter. So now here when T1 is turned on, T2 is turned off. So it is in off position. It is in off position means here, so current is flowing. This is IT1. IT1 current equals to IL1. So that is IL1 current that equals to I0. So this is the I0 current. So this is a plus and this is a minus. What will happen here? Current is produces a positive voltage across the S here, and this S2 means this T2 is in reverse bias. So now here voltage across the commutating in inductances is almost zero. So now here let me write one thing here. So this is the case. So now here we are using RL circuit. It is a constant voltage. So now here V equals to L di by dt. So now here this is the constant, means for constant, any constant parameter. So if you derive, so that value is 0. So this load, this inductor current is 0. So VL1 is equal to 0, means it is, they are connect same voltage and they are connected to with center tapped voltage. VL2 is also 0. And now here VL2 commutating inductance is almost 0. So now here what will happen? So the load voltage is positive, equals to, that is VDC by 2. So now here capacitor voltages C2 reaches at the end of VS2. So now here how it will operate, so that is the case. So now here this is the case. So capacitor C2. So this is the minus plus VDC by 2. So this is the minus plus VDC by 2. So this VC2 equals to what will happen? So minus VDC by 2, this is VDC by 2 and this is minus VDC. VDC by 2 means that is VS, so that equals to so this is the minus. So now here VC2 equals to VDC only, that is VS. So here voltage across the capacitor reaches to at the end of interval VS, it reaches to this voltage is VC2 equals to VS, and VC1 is equals to 0 and VC2 equals to VS, and next VL1 equals to 0 and VL2 equals to 0, and this is turn off. And now voltage across the capacity T1 is 0, that is short circuit. IT1 equals to IL1, and now that equals to I0. So now here what will happen? If you see the diagram, so this is the I0 is constant, and now here I0 current equals to uh, IT1 current. So this is the IT1. So this is I0 current. So now here this is the case, and now this is the case. So now here what will happen? This is IT1. IT2 current is 0. IT2 current is initially 0. IT2 is also not conducting. And now here initially this is the case. So VC1 current is 0. This is a VC1 and VC2 is VS. VC2 is VS. So VC1 is 0 and VC2 is, this is VC1 and this is the VC2 equals to VS. So this VC2 equals to VS and this VC1 equals to 0, and next IC1 is equals to 0, IC1 equals to 0, IC2 equals to 0, and next IT2 equals to 0. So now this is the mode 1 operation. In the mode 2 operation, what will happen? In the mode 2 operation, so T1 will be so T1, how T1 will be turned off. So this T1 should be turned off. So now to turn off that one, at instant T1, SCR T2, that means S2 will be turned on. So this will apply. So what will happen? So now here this is the case. So this is a this voltage is Vs. So this is a Vs, means this voltage is Vs. So Vc1 equals to Vs and VL1 is equals to Vs, same voltage. This is short circuit, and Vc1 equals to VL1 equals Vs. If it is Vs1 VL2 equals to, so the same voltage. So VL1 equals to Vs. So now here if you apply KVL, this is a Vs. So total VDC by 2 minus Vs and minus Vs. This voltage equals to minus Vs. So now here if you apply KVL in this loop, so minus VDC by 2 and minus VDC by 2, and this is minus Vs, this voltage, and next this is minus Vs. So that equals to, so now here, so this is plus and this is plus, and VT1 plus VT1. So that equals to what will happen? So VT1 equals to minus Vs. So now here we are applying the reverse potential. So now here VL2 equals Vs, and the capacitor C1 is charges through L2 and C2, and to maintain the constant voltage, and this will apply voltage across the C2 is same as the voltage across the L2, and this L2 voltage and this voltage is 0, but C1 will discharges through this L1, and this capacitor, this current flowing through the inductor induces voltage into the L1 polarity, and same voltage Vs, and this is Vs, So now capacitor C1 is charges to L2 and S2, and C2 will be discharges. So this is charging, and this one will be, the C1 is discharging and capacitor charging and discharging. So now here this is negative voltage means T1 will be turned off. So initially it was I0 and it will be turned off. This value is 0, and next IT2 current is some increasing, and this is IC2 and IC1 currents, and now here VC1 current is increasing from the 0 and VC2 current will be decreasing. So means capacitor VC2 is discharging and VC1 is charging. So now here in the third mode operation, what will happen? In the third mode operation, what will happen? So this D2 will conduct, and now here this is capacitor, and next here this one. So now here what will happen? This is the I0. This is the I0. So here, so VC1 is equals to V, and VC2 is equals to 0. This VC2 equals to 0. It is just discharging up to 0. So capacitor C2 will discharges, and capacitor is discharges to 0 from Vs to 0, and capacitor C2 is increases from 0 to Vs. So now here IC2 drops down and it will not conduct, and current flowing through will be maintained I0. So that is due to self-induced voltage in it. So the return path for this one is here, that is D2. So the load is inductive in nature. So now here that return path is like this, and now it will try to maintain the current through this load is by self-induced voltage in the load. So the stored energy in the load is then fed back to the lower half of the voltage through D2. So that is the case. So now here IT2 current will decreases in third mode operation, D2 current will decreases. So now here, so this IC2 current will 0, and now here, so this VC1 is maintains constant voltage, that is Vs. So now here in the fourth mode operation, what will have happen? So now here we have only, so this is the case D2, so this is the case D2, and this is L2. So this value is 0, and now here we have only path here like this. So this is open circuit, and when the stored energy is completely dispatched, so IL2 equals to 0. So IL2 equals to 0 means here there is no path here. So now here there is no path here. This IL2 equals 0 means, so initially it was 0 and it is IL2 equals 0. So now here SCR T2 will be turned off. So initially T1 will be turned on, and when T2 will be turned off. So but the energy is feedback to the lower half of this one. It is come back to the D2. So the load voltage is minus VDC by 2, but the load current remains positive. After this SCR T2 can be triggered, so the reverse direction to flow. So this sequence will continue. So I hope this these are the reference books. So PS Bimbra Power Electronics books, that is Khanna Publications, and MH Rashi's books. So these are the reference books, and Umanand Mohan and this publisher. So these are the reference books. I hope all these concepts are clear to you regarding McMurray half bridge inverter and McMurray-Bedford half bridge inverter. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.